So remember, we were looking at interest rate that is compounded several times. And if you recall very well, we said such kind of interest which is compounded several times in a year is called nominal rate of interest. So we derived equation number 9 on how to compute the future value when were given interest that is compounded several times. So we notice that equation number 9 is of high value to us because it enables us to compute the interest rate, the future value when we are given interest rate, and this interest rate is compounded several times. So we notice that here denotes the period in which interest is being computed, and T tells us the time in which the interest or the investment is being done or the loan is being taken. So I left you with an example, example number 8, to say go and complete equation number B and C because we solved part A. But for the sake of this interest, just to remind everybody, so we're going to compute all of them. So let's start. Question 8 says that 5,000 is invested for 3 years at 8% per annum compounded semi-annually. Part A says calculate the total value of the investment, and part B says compare the total return on the investment when interest is compounded annually to that when compounded semi-annually. And part C says calculate the total value of the investment when compounded 1 monthly, 2 daily. Then we need to assume that all months consist of 365 per 12 days. Now, let us start with part A. So let us collect the information that we have. So we know that 5,000 is the amount invested, which is the present value, or in other words, we have P naught is equal to 5,000 kwacha. Then T is equal to 3 years. We are told in a question there, 3 years. Then what about I? I is equal to 8%. 8% means that 8 divided by 100, which gives us 0.08. Then we are told that it is compounded semi-annually. So we can identify there that is, so semi means 2, semi is equal to 2. Now, if we use equation number 9 there, we see equation number 9 tells us that the PT, which is the future value, is equal to P naught times 1 plus I over the power times T. So if we substitute in the respective values, we see that P naught is 5,000 times 1 plus I is 0.08 is 2, the power is 2, then T is 3. So this gives us 5,000, then 1 plus 0.04, that is 0.08 divided by 2, it gives us 0.04. Then to the power 2 times 3, this gives us 6. So you got your calculator, then you punch 5,000, then you're going to have, actually you can start with the 1 plus 0.04. What you're going to have, 1.04, then to the power 6. So this value to the power 6, you get 1.265. Then so you're going to have 5,000 times 1.265,319. And when you multiply by 5,000 there, you're going to get, 6,326.595. So this is the amount that is obtained when 5,000 is invested for 3 years, semi-annual. Okay, so this is what we get. This is part A of the question. Now, let's look at part B. It says that compare the return on the investment when interest is compounded annually to that when compounded semi-annually. So we have already computed the return when interest is compounded semi-annually. Let's look at when interest is compounded annually. So remember that if interest is compounded annually, so we're going to have, so this is part B. So we're going to have PT is equal to P naught, then 1 plus I to the power T. And if we substitute in the respective values, we have P naught is equal to 5,000, 1 plus I is 0.08, then T is 3. So you can start with what is in the brackets. So you have 1 plus 0.08, then you get 1.08, then this to the power 3. So this to the power 3, you get 1.259. So what you're going to have is, you're going to have 5,000 multiplied by 1.259712. Remember not to round off whilst you're still computing. In fact, I prefer keeping this value on a calculator and I simply multiply by 5,000 there so that I don't lose the accuracy. So if I multiply there, what I get is 6,298. So this is a return when the investment of 5,000 is invested for 3 years annually. But recall what the question says. The question says we need to compare this return of the investment when interest is compounded annually to that when compounded semi-annually. Of course, if you look at this, the interest compounded semi-annually is 6,326.595, and interest when the return when interest is compounded annually, we get 6,298.56. So of course, if you compare the two, we see that the one for semi-annually is bigger than the one for annually. So we can see that we're going to have 6,326.595 minus 6,298.56. What we get is, let me see, so 6,326.959 minus 6,298.56. Then I get 28.399. That is if you have not rounded off the values. But if you have, then there'll be a little bit difference in the accuracy. Let me just compute the exact value. So 6,326.95, 0.5595 minus 6,298.56. Okay, so the most accurate one is, if you have rounded off, you're going to get 28.035. So what can we conclude? We can see clearly here that when the investment of 5,000 is invested for 3 years, semi-annually, we get 6,326.595. But when it is invested annually, we get 6,298.56, meaning that the investment of semi-annually gains 28.035 more than when it is invested once. So that's how we would go about this question. Well, let's go to part C. So remember, part C has got two parts. So it says calculate the total value of the investment when compounded monthly. So let's start when interest is compounded monthly. So in this case, that's 1. So still more, the investment is 5,000. So meaning that P naught is equal to 5,000. I remains 0.08. Okay, 0.08. Then let's see, T is equal to 3 years. Let's use formula number 9 or equation 9. So equation 9 tells us that PT is equal to P naught 1 plus I over the power times t. So here we know since the first part says that it is compounded monthly, meaning that it is equal to 12. Because in a year, there are 12 months. So let's plug in these parameters. So P naught is 5,000, then 1 plus I is 0.08 is 12, then to the power is 12 times T is 3. So if you simplify this, what we get is we're going to get 5,000 multiplied by 1 plus. So we're going to have 0.8. So 0.8 divided by 12. Okay. That is a small value, but I would prefer just directly to add 1 to this one. So let me not compute it first. So this, if you convert to fraction, you get 1 over 150. Then 12 times 3, we get 36. So I would first start with what is in the brackets. So I know if I say 0.08 divided by 12, it's the same as 1 over 150, which is the same as 0.0066666. Then without removing this value, I'll just add 1. Then I'm going to get 1.006666667. Then I'll take this value, then I power it to 36. So if I take what is in the brackets to the power 36, I get 1.27. Yeah, so I'm going to have 5,000 times 1.270237. Then if I take the same value, I multiply by 5,000, which is the total investment. What I get is I get 6,351.1 rounded off to 3 decimal places. Now, if you compare this value that we have obtained to that, so we are comparing to the investment compounded annually. Okay, so if we compare the investment compounded annually, we notice that when investment is compounded annually, we get 6,298. So what can we say? We conclude that what we say there is a gain of, what is that gain? We're going to get 6,351.185 minus 6,298.56. So let me compute. So if I have 6,351.185 minus 6,256, we see that there is a gain of, this gives us 52.625. What do we conclude here? We say that when an investment is done for 3 years and it is compounded monthly, when we compare to 1 year, there is a gain of 52,625. So we see the more the interest is compounded several times, the bigger the return. Let us look at part number 2. So part 2, just create a small board here. Part number 2, it says we need to compare this when interest rate is done daily. So part 2, so what does it say? Say daily. So daily, we assume that this, in a year, there are 365 days. Okay. So we still use our formula. Let me just get this bigger one. Okay. So if the interest is compounded daily, we see that now we're going to have P naught, PT is equal to P naught, 1 plus I over the power T. But this time around, T remains 3. What about, so is equal to 365. Why? Because we have this is compounded daily. So daily, there are 365 days in a year. So 365. I remains the same. I is equal to 0.08. So if you substitute in into our formula there, these parameters, we're going to have PT is equal to 5,000, then 1 plus I is 0.08 divided by 365. 365 to the power is 365 times T is 3. So what can help us compute this one? So you go to your calculator. So I'll start computing 0.08 divided by 365. Then I'll have that one. Or maybe before that one, let me start with computing what the power is going to be. So the power is going to be 365 times 3. So it's going to be 1095. So let me just write this one. So I have 5,000 times 1 plus 0.08 over 365 to the power 1095. So next I'll go to my calculator. I'll say 0.08 divided by 365. Then I'm going to add 1 plus 1. So meaning that in the brackets, I'll have 1.000219178. Then I'll get this answer without changing anything. I'll power it to 1095. Then I press equal, I get 1.271. So I'm going to multiply 5,000 times 1.271 to 157. Then if I multiply that answer by 5,000, I get 6,356.079. Now, if you compare this answer to the return when interest is compounded annually, we see that there is a gain. So in other words, there is a gain. So there is a gain of, what is the gain? The gain is 6,356.079. If I subtract this subtract this 298.56, which is the gain when interest is compounded annually, then what I get is, so let me subtract 6,356 or 6,356.079 minus 6,298.56. I get a gain of 57.519. So this means that when investment is, the investment of 5,000 at the interest rate of 8% compounded daily for 3 years, we see that you are going to gain 57.519 compared to the gain when interest is compounded annually at the same rate. So this is all about the nominal rate of interest and how we can solve example number 8. The next part of our lecture is to look at continuous compounding. Can we have a situation where interest is compounded continuously? Oh yes, so here is for simplification only. So continuous can mean every minute, maybe every second, every day, or every month, depending on the context. Now, when interest is compounded continuously, then the formula changes a little bit. So we still use the same formula. So if you look at this here, what we have in equation number 10, we know, since interest is being compounded continuously, so meaning that is getting larger and larger and larger. And as a result, we take a limit. So as approaches infinity or a bigger number, then we see that this value here approaches e to the power I. Now, This e to the power I, remember here there is a t. So if there is a power to the power, we see that those powers, they multiply. So what we end up is we're going to have I multiplied by t there. So we have P naught is equal to e to the power it. So to find the future value, when interest is compounded continuously, the formula is simply P naught e to the power it, where I is the rate of interest and t is the time of investment. So to put this into proper context, let us look at an example, and we're going to solve example number 10. So example 10, it says, a financial consultant advises you to invest 5,000 at 8% compounded continuously for 3 years. Find the total value of your investment. Now, what information do we have here? We have P naught. So we have P naught is equal to 5,000. What is I? I were given that is 8%, which means 8 over 100. This is same as 0.08. Then what is T? We are told this is compounded continuously, and T is equal to 3. So the key term is continuously there. So what is the formula? If you look at equation number 10, we can see that we can find the total investment there, or total value being equal to PT is equal to P naught E to the power IT there. So substituting in these parameters, P naught is 5,000. So we're going to have 5,000 there. Then I is 0.08. So we have 0.08 and T is 3. So you got your question there, to your calculator. Remember, some of the calculators are limited. So what do? You start computing the power there. So what is 0.08 to the power 3? So we're going to have 5,000 e to the power. So if you multiply 0.8 times 3, you'll get 0.24. So you're going to have e to the power 0.24. So according to your calculator, you're going to press 0.24, then you go shift, then E, then that answer multiplied by 5,000. But my calculator can do directly that. So I can compute E multiplied by, 5,000 multiplied by E. So I've got my shift E to the power 0.24. Then automatically I'm going to get my answer. Let me just see. So I get my answer, which is 6,356.246, rounded off to 3 decimal places. What has this example taught us? We see that when interest is compounded continuously, then, when interest was compounded annually, in the example that we looked at, we noticed that the value of the investment after 3 years was 6,298.595. And if you compare with when interest is compounded continuously, we see that we have 6,356, and there is a gain of 57.74 when you compare it to the interest compounded continuously. So when interest is compounded continuously,